Hey everyone, Mr. Newman here. Today we're going to learn about scatter plots, and the first part is going to be real fast, but the later part is going to use your calculator, so make sure you have your calculator before you get started on this. Alright, so a scatter plot graphs points or data. Notice all these examples of scatter plots, they don't need to be functions. You notice some points are directly above each other. However, the line that we are using to model the scatter plots will typically be, or will always be, a function. So, what line am I talking about? Well, if you try to draw a line straight through the middle of those points to represent all those points, we call that the line of best fit. And we also call it the regression line or the least squares line or the trend line. I'm going to use line of best fit here, but whatever it's called, it's the line that is closest to as many points as possible. Notice that second line would look like that, but the third one, the data is all over the place, so we have a name for those things. The first one would have a negative correlation because the slope of the line is down or is decreasing. The second line would have a positive correlation because the line is going up or the slope is positive and the line is increasing. And the third one there would have no correlation because shoe size and the colors in the rainbow don't really have any relationship to each other. So, what does that mean in terms of strength of correlation? That's another way to describe the data. Well, you notice down here I have a strong correlation on that bottom left box. And the reason for that is because if I draw the trend line, all those points are pretty close to that line. However, data can have a weak correlation if, for example, I draw the trend line here, and those points, even though the trend line looks the same or nearly the same, those points are not as close as in my first data set. So data, or scatter plots, can have strong correlation or weak correlation, and they can have a negative, positive, or no correlation. And you can think about, okay, why does, for example, the time it takes to run the 100 meter and the amount of time spent training, why would those have a negative correlation? Well, the more you train, the less time it's going to take you to run the 100 meter. Likewise, time spent studying and student grades, the more time you spend studying, typically the better your grades are in class. And like I said, those first two, the colors of the rainbow and shoe size, those are just ones I made up. Those don't really have any relationship. So, what do we do with these? Well, here are the instructions for how to type and find a line of best fit from your calculator. However, you guys know I don't like to just leave you with instructions. I'm going to show you step by step right here how to do it in the calculator. So go ahead and grab your calculator right now if you don't have it yet, and make sure that you are doing each step as I do it. So, first of all, our goal is to type in this data right here. Okay, that's our practice data, and we want to find the line of best fit for that data. So, turn your calculator on and press the Stat button. It's right there in the top center of the calculator, just below the Delete button. Then this menu should open up where you see Edit, Calculate, and Tests up there. And then 1 through 5, Edit, Sort A, Sort D, Clear List, Setup Editor. We want to hit Enter to go to the Edit menu, or you can press a 1 in. Now, if you're like my calculator, you had another list already in there. If your list is empty, great, you can ignore this for now, but you might want to listen just so that you know how to delete entries, because you'll for sure be doing this and using this over and over. What I would recommend is go to the top of the list like I did and just press the Delete button. And each time you press Delete, one entry will be removed on that list. You can keep pressing it until it's all clear. There's another way to do it a little faster, but you need to be very careful. If you press the Up button, then it takes you to the top of the list up there. Do you see how I'm now highlighting L1? And you can clear all those. However, do not press the Delete button there. I repeat, do not press the Delete button. If you do, you delete the entire list, and you'll probably need my help fixing your calculator just so you can do this again. So, do not press the Delete button there. Instead, press the Clear button. That's why I recommend using the first method where you just delete the entries so you don't risk deleting the whole list. However, you can, if you're adventuresome, go up and press Clear instead of Delete, and it will clear the list and make it empty for you. So, looking up here now, hopefully your calculator started like this. You have no entries, but you have list 1 and list 2 at the top. That's actually very important. And then list 3, and if you press right, it'll go on to list 4 and so on. But list 1 and list 2 are the first two that should be there. And you can go ahead and type in all the numbers from the worksheet. So on the L1 will be 2, 2, 4, 5, and 7. List 2 will be 3, 4, 5, 7, and 8. And notice it's very important the order you type these in, because you want L1, the point, to be x comma y. So 2 comma 3 is that first point. 2 comma 4 is the next point. So you do need to type all of them in. If they don't match up, where you have one list is longer than the other, then when you go to graph it or go to find linear regression, you'll get something that says error invalid dim, which just means invalid dimension. In other words, the lists are not the same, so you can't find a regression when you have more x's than y's, for example, or more y's than x's. So make sure that those lists are the same length and you typed them all in. And then I want to show you guys real quick how you can graph them. Oftentimes we're graphing these. We're not going to do it on the sheet now, but I just want to show you on your calculator can do it for you. If you notice, I clicked y equals, okay? Once you click y equals, you want to look up there. There are these plots at the top, and that's a way for you to plot different points. So if you press up to go to the plot, then you're now highlighting the plot, and you want to press enter. That way the plot up there is kind of highlighted black, kind of like mine right there. When you press graph, then it'll take you to the screen, and you'll notice we plotted the data. You can go back to y equals and turn that off just by hitting up and then enter again. And that is what the data looks like. Now notice that this is not a function. And we knew that going into it, because you look, you have x is 2, y can be 3, or x is 2, y can be 4. That's not a function, but because it's a scatter plot, that's okay. Our line of best fit will be a function that models this data. So let's show you how to get the line of best fit. Well, first you're going to press stat, okay? And once you press stat, it'll take you to the edit list again. But instead of pressing edit, I want you to go to the right to calculate. So press right 1, and you should get a menu that looks like this, calculate. So stat, then right 1 to get to calculate. Now you'll see a bunch of things, and we want the fourth one, linreg. Okay, that's short for linear regression. That's one of the names of a line of best fit. You also notice right there, ax plus b, it gives you the format. Now, we are used to y equals mx plus b, but the calculator just likes to use the letter a instead of m, which is fine. And it's going to tell us exactly what is the best slope and what's the best intercept for this set of lines, or for this set of points. So you go down to 4, or you can press the number 4, and you're going to press enter. So go down to 4. And notice that linreg stands for linear regression. Notice that is a line. 5, if we wanted to use 5, that'd be a quadratic regression. 6 would be cubic, 7 quartic. Those are things we haven't talked about in this class. A quartic is x to the 4th power, in case you didn't figure that out, just like cubic is x to the 3rd power. But when you press enter, then you get this menu right here. And notice it says the X list, well, we wanted that to be L1, right? We want the Y list to be L2. And so you can just check and make sure those are correct. If your list was broken and you didn't have L1 and L2, and instead maybe you type this into L2 and L3, or L3 and L4, the L's are all right here on the calculator. You notice L1, L2, L3, L4, L5, L6. So if you need to type in L3 instead, for example, you can press second, then 3, second, then 3, then you can type those in. But don't do that if yours is already set up correctly. So this L1 and L2 is exactly what we want, because we typed ours in correctly, and you want to press calculate. That involves just pressing enter like 5 times in a row to get down to calculate. So press enter, enter, enter. When you're on the bottom, press enter one more time, and you should get this. Here is our linear regression. Notice it's in the format of y equals mx plus b. The calculator just says a instead of m, which is fine. But that means our slope is 0.944444. I'll just round to the nearest thousandth there. X plus our y-intercept is 1.622. And the predict here, so this is our line of best fit. We just found our line of best fit. The next thing we're going to do is use that model to predict what if x was 3. Notice we don't have x being 3, but we can make a guess as to what it might be. And we're going to plug that into, whoops, let's see here. We're going to plug that into our, there we go, plug that into our equation. Plug in 3 for x. And when you do that, you can type that into your calculator. You get about 4.45. So our trend line suggests that if you had a 3, it would be somewhere around 4.45. Now notice a few things. I use the squiggly lines for approximation. That means about, because I did have to round it. And notice I did round to the nearest hundredth. That 5 is a hundredth, 5 hundredths. And that is how you find a trend line. Go ahead and try doing that. Use your calculator to find the trend line for this next one. You'll need to clear the list or delete each entry and have 2 blank entries on L1 and L2. And you're going to find the line of best fit for that data. I'll pause the video now and let you do that. All right, did you find the line of best fit? So just to check and make sure, stat edit should look like this. Your lists should look like this. And when you go to find the linear regression, it should look like that. So our equation is y equals negative 12.54x plus 114.19. The prediction is, what if Arthur watches 6 hours of TV? What score do you think he'd predict? Well, you have to notice x is hours of TV. So we're going to predict that when we plug in 6 here, we think that Arthur is going to get a 38 on the quiz. Not very good, Arthur. You shouldn't watch so much TV and study instead. Cool. What if Betty watched 10 hours of TV? Well, this is kind of a silly prediction because if the slope is negative, it's going to keep going down, 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 down. And if we plug in 10 here, we actually get a negative score. Whoops. Which is not possible. So even though the predictions, our model says negative 11.21, we might want to be smart about it and say, hey, the lowest score you can get in Mr. Newman's math class is a 0, so your grade is probably going to be a 0 instead of a negative 11. Maybe you shouldn't watch quite that much TV though, Betty. All right, thank you for watching, and I hope you learned something.